This is going to be the last section of chapter 8 or whatever the chapter was on radicals. Okay, so this is going to be complex numbers. So far we've been doing problems where we had the square root of -2 gives us no solution. So anything that has a negative in the inside gives us no solution, or no real solution, I should actually say. So we get something that looks like that. Okay, now with complex numbers, we are going to introduce a new type of solution. So we're going to start off with the square root of -1, and what we're going to define this is with an I. Okay, this I is what we're going to call imaginary. So this is an imaginary unit. So whenever you see I, this is going to be equal to the square root of -1. Now you might be wondering, why are we using imaginary numbers? Well, imaginary numbers are used in a lot of fields in engineering. Some problems are really easy to solve by converting to complex numbers. So complex numbers are used in real life. They make problems easier to solve. But let's just play around with a couple of complex numbers, because they will appear a lot with quadratic equations, which is going to be the next section. So let's say we are defining this, so really know that I is going to be equal to the square root of -1. So when we go back to the square root of -2, well, we can decompose this as the square root of -1 times the square root of 2. All right, well, the square root of -1 is just equal to I, and this is just going to be square root of 2. So that's how you would simplify this thing. Okay, so how would you simplify the square root of -4? Well, this is just going to be decomposed as square root of -1 times square root of 4. Square root of -1 is just going to be I. Square root of 4 is just going to be 2. So the way that you would want to write this is 2 times I. Okay. Now, if there's no square root, we would conventionally write the I in the after the number. If there's a square root, we write it beforehand. Okay. So what do you think square root of -9 is going to be? Okay. So you can try this out, and then you can also try out the square root of -8. Okay, so you can pause the video, try to figure out what these two are, or you can just do it with me. So this is going to be square root of -1, square root of 9. This is just going to give me an I, times the square root of 9, it's just going to be 3. So my answer is 3I. Okay, this one, we're going to have square root of -1 times square root of 8. Square root of -1 is going to be I. Square root of 8, well, this can be decomposed as 2 and 4, and this is 2 and 2. I can take out a pair of 2's, okay, and I'm left with a 2 in the inside, square root of 2. So you can write this as 2I square root of 2. Okay, so that's all there is to these I's. Okay. Now what we want to do with these complex numbers, this I is really what we call a complex number. And a complex number can be written as the following way. So here's the notation. It's A plus BI. So this A is what we're going to be calling the real part. Okay, so that's the part that's real. Okay. This part, this BI, is what we're going to call the imaginary part. Okay. All right, so the imaginary portion is going to be with an I. Okay, so the real part and the imaginary part. Okay, so you're going to see different types of complex numbers. So you might not just see just 2I or I. You might actually get 3 plus I, or -4 minus 2I. So all of these are complex numbers. Okay, so what we're going to be doing with these complex numbers is the following thing. So what we're going to do, we are going to add, subtract, multiply, and divide complex numbers. Okay? So first we're going to start with adding and subtracting. And actually, adding and subtracting is not too terrible. All we got to do to add and subtract, we just want to combine like terms. Okay, so that's all you really want to do. So let's do an example. So let's say we have 2 plus I plus 3 minus 4i. Okay, so I want to add these two complex numbers together. So the first thing that you want to do is basically combine the like terms. So here, this 2 and this 3 are like terms. So 2 plus 3 is going to give me what? That's going to give me 5. Okay? And then the other like terms is going to be this I, which is positive, plus this negative 4i. So I plus negative 4i is going to give me negative 3i. Okay? And that is my answer. So all we're just doing is just collecting the terms that are like terms. Okay? All right, so let's do another example. So let's say we had negative 7 plus 2i minus 4 plus I plus 2 plus 10i. Okay? So let's first start off with this first two complex numbers, so this one, and then we'll take care of the other one. One thing that you can do is you can distribute this negative. So you're going to get negative 7 plus 2i. The parentheses don't really matter. They can be dropped. Minus 4 minus I. Then this plus, you can distribute it too, but it's not really going to do anything. It's just going to be plus 2 plus 10i. And all we got to do is just collect everything that is like terms. So here is a minus 7. Here is a minus 4. And here is a plus 2. All of those are like terms. So negative 7 minus 4 is just going to give me negative 11. And then negative 11, so this was negative 11. And then negative 11 plus this 2 is going to give me a negative 9. Okay. And then we're just going to collect the other ones. So we're going to collect this positive 2i, this negative I, and this positive 10i. So 2i minus I is going to give me 1i. 1i plus 10i is going to give me 11i. 11i. Okay? Okay? And that is going to be the final answer. Okay? So that's all there is to adding and subtracting these complex numbers. Okay? Now let's do multiplying. Okay? So let's say we want to multiply these complex numbers. So multiply complex numbers. Okay, multiplying is super easy. Keep in mind though, you might be having to use this identity. So I know that I is equal to square root of negative 1. So what do you think I squared is equal to? Well, I squared is going to be the square root of negative 1 squared. And what happens when I square the square root? It goes away and I'm left with negative 1. So I squared is equal to negative 1. So this one, make sure that you really know. We're going to be using it a lot. Okay? So here's my example. My example is to multiply. So let's first start off with this. Let's say we had part A, 2 times 3 minus 4i. Okay? This one's pretty simple. All we gotta do is just distribute this out. So we're gonna have 2 times 3, which gives me 6, minus 8i. And that's it. Okay, so just a number being multiplied to another complex number. Okay, just distribute it. Okay, what about if I had 3i times 1 plus 2i? Okay, so how is this gonna work out? Well, first let's distribute this 3i to both of these. So we're going to get 3i plus 6i squared. Okay? And what was I squared equal to? Well, I squared was just equal to negative 1. So I get 3i plus 6, and then I squared is just equal to negative 1. So this part was just negative 1. And this is just going to give me what? 3i minus 6. Or you can rewrite it as negative 6 plus 3i. Okay, by just switching these two around. Okay. All right, let's do two more. So let's say we had 3 plus 2i, 1 plus 2i. Okay, so you have a complex number times another complex number. Okay, so what you want to do, you want to FOIL this out, just kind of how we've done it before. So 3 times 1 is going to give me 3. That was the first term. Then I'm going to do the first one times the last one. 3 times 2i is going to give me plus 6i. Then this 2i times this 1 is going to give me plus 2i. And then 2i times 2i is going to give me 4i squared. Okay? So now this 3 is going to be left off by itself. I'm going to combine these two together. 6 plus 2 is going to give me 8i. And then I have plus 4i squared is just going to give me negative 1. So I'm going to be left with 3 plus 8i minus 4. And then I can combine this 3 and this negative 4 to get negative 1 plus 8i. Okay, so all I'm just doing is just FOILing everything out. Okay, all right, and now let's do one last problem. Part D. So let's say you had 1 plus 2i, 1 minus 2i. Okay, do you remember what these are called when the number or the sign on the inside are different? Well, if you forgot, these are what we called conjugates. Okay, and remember when we had conjugates, this was really useful when we were rationalizing. Okay, so remember that a lot of things canceled out. So let's see what happens. So I'm gonna FOIL it out. 1 times 1, that gives me 1. 1 times negative 2i gives me negative 2i. 2i times 1 is going to give me positive 2i. And then 2i times negative 2i is going to give me negative 4i squared. Okay, so what I'm left with is 1. This is going to cancel out. And you're left with minus 4. The I squared is just negative 1. So you're left with a 1 plus 4, which gives me 5. Okay, and that is my final answer. Okay, so actually I ended up getting a number on the bottom, so which is actually really good. Which brings us now to division, which is our last topic. Okay, so division is very similar to rationalizing. So let's say you had 1 plus 2i divided by 1 minus 3i. Okay, so how do you divide these two complex numbers? Okay, so really what you want to do when you have a division, you just want to multiply by the conjugate. Because what happened, what you saw here is that when I multiply by the conjugate in part D, you saw that in the end you just get a number, so you get rid of the I. So we don't want an I on the bottom. So I'm going to multiply by the conjugate. In this case, the conjugate of the denominator is 1 plus 3i. So I'm going to do that to both top and bottom. Okay, and what I'm going to get is 1 plus 2i, 1 plus 3i, divided by 1 minus 3i, 1 plus 3i. Okay, so now let's FOIL everything out. 1 times 1 is going to give me 1. 1 times 3 is going to give me 3i. 2i times 1 is going to give me 2i. And then 2i times 3i is going to give me plus 6i squared. The bottom part is going to be 1 times 1, which is 1. Then 1 times 3i, which gives me 3i. Negative 3i times 1 is going to be negative 3i. And then negative 3i times positive 3i is going to give me negative 9i squared. Okay. So now what we're going to do, okay, these things are going to cancel out. So these bottom parts go away, okay? And what's left on the top? On the top I have 1 plus 3i, and then 2i is going to give me plus 5i, plus 6, this I squared is going to give me a negative 1, divided by 1 minus 9, I squared is going to give me another negative 1. Okay, so on the top I'm left with 1 plus 5i, then 6 times negative 1 gives me negative 6, divided by 1 negative 9 times negative 1 gives me a positive 9. Okay, I'm going to combine these two together. I'm going to get a negative 5 plus 5i divided by 10. Okay, all I got to do now is just, this 10 is being divided by both of these things, so I can just write it as negative 5 over 10 plus 5i over 10. So I just broke up the fraction. And I can simplify this a little bit more. This will be negative 1/2 plus 1i over 2 by just simplifying it. And this is just the answer. Okay? So when you want to divide two different complex numbers, all you got to do is just multiply by the conjugate. Okay? So that concludes all of these sections. So this one was a lengthy section. It was a lot of work, but if you have any questions, please don't hesitate to let me know.